All right, so my name is Norm Lastovica, and earlier this year, VSI asked me if I put together a little presentation about SCI's experience on x86 VMS, and I said maybe, and then they said we need commitment, and so I said yeah.
Say definitely maybe.
Yeah, definitely maybe if it's convenient. So please feel free as we go along, interact, ask questions and stuff. I promise to use up the entire time, whether I have material or not. I don't know how to go to the next slide.
Right here.
What?
Right here.
Yeah, I'm at least.
Click on the
Mouse button,
and then we're in.
There we go. Okay. So a real little bit about me before we get started. I've been working on VMS since well, version 1 field test, as it turns out. But prior to working for a company called Digital, I did microcode and this and that on different computers and architectures. I worked for a company called Digital for a number of years, doing applications and systems architecture and design, porting to Alpha. I worked for a company called Oracle for a while and did some more porting, some more performance work. And then for the last few years, I've been working for SCI, doing systems and applications and architecture consulting and performance, and turns out more porting. So I'd like to waste a little bit of your time this morning. We'll talk about some history, a little bit about SCI, our experience building, cross-building, native building, some of the challenges we had along the way, and then a little bit of extra stuff that's not on here. So, and a lot of this is repetition from what you've already heard from all the people at BSI over time, but basically, since decades, we've run VMS on x86. We had VAX emulators, we had alpha emulators, number of different ones of each. Then we started hearing rumors about people wanting to port. Sure, everybody wants to do everything. Then in the middle of all that, HP abandons one thing and abandons the hardware that one thing runs on. BSI arrives, and then the rumors got stronger. And then eventually rumors turned into announcements, and then announcements turned into software, and then software turned into operating systems. So to sum it all up, we've been running on x86 for a very long time. Running native is kind of an exciting addition to that story. So back in May of 2020, I received an email, and I was going to show you that it was actually quite nice, very flattering. But are we ready for an experiment? Sure. And the experiment was, we're going to be the first outside of VSI location to run x86. And so I suppose they got to the point where they felt like the PowerPoint slides were successful enough that they could now share the PowerPoint slides with other people, and hopefully it still works. Days later, we received a big container file, a bunch of documentation written by engineers. So many of the sentences had both nouns and verbs and went in a logical sequence. And within, I don't know, within an hour, we were up and running. It was very anticlimactic, right? I destroy this container, you do all these things in your virtual environment, and you push the button and you get a prompt. And you type show system. I mean, it looks just like how it always does, which is pretty impressive. I mean, yeah, it sounds really innocuous, but there's a tremendous amount of code that has to run to get to this point. All that code had to be built and debugged and ported and all these things. So anyways, that was my proof that it happened. So great, we've got an operating system, runs on a computer. So what? Nobody buys a computer to run an operating system. They buy a computer to run an application, to run their business. So over the years, as I mentioned before, I've been involved with moving a lot of software from a bunch of different architectures to a bunch of other architectures. Some of those ports have been casual. You know, you copy the module over, you compile it, you link it, you run it, you're done. Other ones are arduous. You know, a whole bunch of macro 11 code or code that make incredible assumptions about the particular piece of hardware that you are running on and the behavior of this instruction, and it set a bunch of these other bits along the way, and so it's everything, right? Some are easy, some are hard, but you know, SCI has been involved in VAX to alpha and VAX to integrity and alpha to integrity and on and on and on. A bunch of the software that we've ported is our own, written in-house, part of our tool set. A bunch of it's some freeware thing that's been around for eons and run on every version of Windows and Linux and Unix and Solaris and whatever. So they're all different. And then there's plain old customer commercial applications. And we'll talk a little bit more detail as we go along. So having done this a couple times, what were my expectations heading into this process? I figured it was going to be easier than alpha to integrity. VAX to alpha was hard, for sure. Alpha to integrity was pretty straightforward. Here, I figured it was going to be easier still. If an application runs on integrity day, if you can compile it and link it, there's a really good chance that it's going to do the same thing on x86. That was my expectation. So compile, link, if you need to test, and then deploy production. However, where we start out, the environment, the ecosystem that we're working in, basically the same. The compilers, the DCL commands, the tools, all of those things work exactly as you'd expect them to. The FDL editor, yeah, create, convert / FDL, sort, all of that stuff is the same. The system services, the library routines, same documentation, same parameters, everything goes. The compilers mostly are the same thing. The front end's the same, the language is the same. Yeah, there's some differences, there's some boundary cases. If you're programming in PL1, anybody? Okay, that would be a disappointment. But other than that, pretty much good to go. Documentation, anybody read it? Read it? It's astonishing. Yeah, written it. It's astonishing the amount of information about the operating system that's in the documentation set. And I've talked to customers like this week, in fact, basically had no idea that there's a whole manual about system services. Every single one of them with its own page, and it's the list the arguments and the return status and what the return status means. It's fascinating. So do yourself a favor and at least know that link. All right. One of the mistakes we made during the alpha to Itanium port is we talk way too much about floating point. We had hour-long presentations about how scared you should be of all these differences in floating point. At the end of the day, I don't think that was worthwhile investment in our time. You have a random number, you have a floating point number, you have an integer, they're numbers. If you're using floating point, you already are using an approximation, right? So is this approximation more or less bad than that approximation is what the question boiled down to. Yeah. Which number is closer to reality than the other number? The differences are small. So yeah, we made a big deal about it. Probably wasn't necessary. It's not 1986 anymore. We're not porting from alpha most of the time anymore. So if you have yet to move to IEEE floating point in your application, and also you care which almost nobody does in the real world. Build your application today with IEEE floating point on alpha or 10. Not that big of a deal, but just get it over with. Where everybody gets bit is calling libdollar_weight, which I think is one of the most abused runtime library routines in VMS, because why did my employer spend hundreds of thousands of dollars to buy this beautiful new computer with all this storage and this great operating system? And the first thing I want to do is not compute. I don't get it, but anyhow, pay attention to that one. I got challenged at a presentation many years ago. Well, the differences in floating point are down in the, the 18th bit of the fraction. Said, yeah, okay, that's true. However, here is a tiny little basic program that came out of the RDB regression test suite, coincidentally. That's how I found this. And yeah, you can demonstrate very simply that a innocent operation like 116 and 331 divided by 10 give different answers. All right, so questions about floating point? Don't be afraid of it. Just port anyhow, deal with the problem if the report at the end of the month is wrong. If at the bottom of the accounting spreadsheet you get a different answer, you already have a bug because you're not supposed to use floating point for money.
My neighbor is saying it matters more than your.
Unless you have a few more, don't do one something macro.
Okay. All right. So there are some funny. All right. So during the port of RDB, we use an approximate log value by taking the mantissa out of a floating point number. It's a close approximation. So we convert everything to T floating point, and now the optimizer goes to heck because we're choosing all these terrible solutions for all these queries because we didn't recognize. And then of course it's stored in inverse bit format with the sign. Yeah. Data alignment, another thing that we harped on tremendously.
Many sessions.
Many sessions, many hours and bits have been wasted talking about data alignment. On backs, didn't really matter very much, and it was hidden from you anyhow. Alpha, it mattered more, but the hardware and the PAL code helped us out a little bit. So yeah, it was bad, but most people got away with it. On integrity, it was terrible. Mattered a lot. So again, we spent all sorts of energy talking about data alignment. Now we're back on x86 and it doesn't matter anymore. So if you avoided fixing your application for the last 20 years, you've done well. Yeah, the clothing style has returned. Don't bother to fix your alignment now. If you haven't done it yet, you're fine.
Interesting side story to this.
Yes, please.
On Alpha and Titanium, our code generator always did alignment. We added alignment holes to try to ensure proper
Yes.
alignment.
You
And
helped.
x86, we helped, but it also meant we sometimes helped by covering up bugs in the application. And so we found going to x86, the backend, your alignment doesn't matter, so no alignment holes. Variables on the stack are right next to each other. And if you have a program that went past the end of the right, or if you have a program that wrote a 64-bit value to a 32-bit variable, on Alpha and Titanium, you almost wrote your variable and an alignment hole that no one cared about. Here in x86, you wrote your variable and some other.
So absolutely true. I mean, there is differences under the
Alignment
covers.
is- The compiler trains very different code, and because of the lack of alignment care,
Yep.
we will expose other bugs in the code.
Yeah, we'll talk about not bug for bug compatible. And I'll tell you this right now, just because your program works doesn't mean it doesn't have bugs. And we have some fun examples of those. So step one, if you're going to be doing this port, if you can compile your application today, do yourself a favor and turn on the check and warning and all of the things that the compiler can do to give you hints, do them now. Upgrade your alpha and integrity compilers to the current versions now. It will help you later because you're going to find bugs. Some of them are going to be obvious. Some of them you're going to argue about, and almost always the compiler wins those arguments. Stack layouts are different. Memory layouts are different. The calling standard's different. Lots of things got moved around. Uninitialized variables that you got away with maybe before, you're going to be punished for it today. Sometimes a little bit, sometimes a lot. So what's worse? I run my program, blows up with an access violation. Or I run my program and the answer is different. What's a worse latent bug? You tell me, but they're there. Timing of things, and what I'm referring to there is some operations on x86 are going to be slower or faster than the corresponding operations on the other architectures. So things that you got away with in the past, maybe the order of events or asynchronous events between processes, those may become more exposed. Again, just because your program works doesn't mean it doesn't have bugs. Okay, on disk, same thing. Same ODS2, same ODS5, same RMS index files and relative files and sequential files. None of that stuff is different. Certainly there were opportunities to make improvements in those areas, but those improvements would have been incompatible, and then you would have complained about that instead. So you can't win. No, we don't even try. TCP/IP version 6 has been talked about. My experience is the bulk of it's the same as before. A bunch of components got refreshed. The OpenSSH dashing that happened in the last session, yeah, it's largely compatible. It's mostly the same, except for all the places where it's not. I would say don't wait 2 more years for version 7 to solve all your problems. Change your command procedures now. Train yourself to use the -V7 qualifier, whatever you need to do. Just do it. Yeah, just go ahead. Don't be afraid of it. It works. The SSH key formats, if you're interoperating with other things, you're going to solve a bunch of your problems and you're going to create some other problems. So you'll need to learn how to convert the keys back and forth between the formats. But again, just do it. It's not scary.
So, we refreshed NTP.
Yes, NTP is new.
Refreshed line that. It's you get a sec. Field set was required. It's not.
Yes, so the point was NTP is new, Bine's new. I'll also share with you that NFS is way better than it was. Is it perfect? No, but it's way more reliable, way more robust so far. So the CPU, 99% of business application managers and developers and stuff don't need to know anything about any of this. Okay, it's the VAX had sort of an elegance to it. The alpha was super thought out and engineered. The Itanium was designed by a bunch of independent teams that hated each other very much.
Drugs, there's a lot of drugs.
Yeah, there was a lot of recreational drugs going on when that was designed. x86 was designed ultimately back in the 4004 days, back in the 1970s, and somehow the combined efforts of human intellect have resulted in that same architecture growing and growing and growing. We used to talk about like certain computers would have a bag on the side, like, oh, we're going to add this new math code processor to some old machine. And it was just kind of an ugly extension. x86 is that once a year for the last 40 years. It's ugly extension after ugly extension. So the less you know about it, the better off you are. Don't program an ASM. Don't look at your compiler listings, just run your program. Calling standard, it's family similar since all the way back in the VAX days. And yet there's a bunch of differences. Again, almost nobody programming commercial applications cares, and you should not. If you feel like you need to, read that document, then decide if you still feel like you need to. You know, if you're developing real code and important things, yeah, know the calling standard, but what goes in what register and what is unwound on the stack, and don't worry about it. And if you have any questions about the calling standard or what happens, John Reagan's email is included at the very end of this presentation.
What's cell phone number?
Oh yeah, call him anytime, day or night. Okay, so that's my take on porting and the stuff you need to know about. Now, as far as SCI, what happened? So back in May, when we first turned the system on. So all along, because possibly we were an early adopter, our internal environment is OpenVMS, since whatever it was, E9.0, whatever, running on a Linux Oracle virtual machine, running on VMware, running on some hardware we had. This is not a performant environment, not incredibly the easiest environment to configure and use. And it's been really funny along the way. We'll find some bug, whatever it is, and report it to VSI, and VSI will say, well, you know, it's your stupid environment that you're running, before fixing the bug in VMS. Like, they never miss the opportunity to blame our hardware before they fix their software. Don't do this. Like, if you're thinking about if you're thinking about which virtual environment to choose, it's not this.
Choose them all.
Choose them all. Yeah, use them all. We probably need a KVM as an extra layer. Anyways, so this is our current, you know, our main cluster. It's three architectures, and originally was to be 4. So we've had a VAX in this cluster since forever. 92 boot it, enter the cluster, won't enter. Well, it's because there's a version 6.2 system that 9 can't communicate with. Thank you very much, Doug. So rather than going through the incredible effort of upgrading a VAX from 6.2 to 7.3, I just took it out of the cluster.
7.2 will work. 7.3 is supported, but 7.2 will work. The cluster protocol version numbers are not that fine grained.
We only do things that are.
It's still easy to take.
Yeah, we only run supported software, so you can see why.
You have to ask yourself a question. What features are you looking how to build
With old
with an advocate?
Yeah, I know. So anyhow, I guess the upshot of this whole thing is I'm not building our tools on VAX right now. And if that's a problem for you, get in touch with me. Get in touch with Doug.
That was the best question.
Yeah, 2 years later, he's still laughing about
You know,
it.
I have a few others too.
All right, so our build environment, a bunch of different languages, not including C++, thank you very much. A couple thousand modules broken into components. We build for VAX Alpha, Integrity, and x86 on multiple different versions of each. So just, I mean, not that it matters to you. Some of our alpha tools need to get built on 7.3 as well as 8.4. Knowing what I know today, we wouldn't do it the way we did, but yeah, so I've got copies of old system disks mounted that we can reference just on the library and just on a load of languages and stuff. batch queues per platform, whether it's cross or native. It's a solution in search of a problem. However, it also works. So just like everybody else, we started out building everything with the cross tools. So we run some compiler on integrity and then the cross linker on integrity. And at the very beginning, we didn't have any network capabilities. So we had these container files that we automatically would be able to move back and forth and reboot the other machine when we needed to copy one more image to fix one more bug. Over time, as more and more things have become available, in terms of compilers and tools and stuff, slowly migrating back to 100% native. I'm almost there. There's a handful of components that are in my way. There's a couple of open source tools that the build procedure, the command procedures that they surrounded their software with are much more complicated than the software itself. And I just ran out of enthusiasm to try to figure out how to make it work. And then there's a couple little missing bits and pieces. I mean, RDB, DBMS, SDL, that kind of are a pain in the butt. And because they're a pain in the butt, they've exceeded my my ability to generate enough motivation to deal with it. So I just skip it. And someday I'll have SDL, has been the message. Yeah, I know. Everybody else has it. All right. So what are you going to have to do when you port your application? Almost for sure your code is not going to have to change, or if it does have to change, it's going to be super minimal. Where you're going to spend your time is your DCL build procedures, the wrappers around stuff, the if def, if not def, if defined, not defined and stuff. Had we known 40 years ago that this was going to happen, nobody would have said, if alpha, then else do the VAX way. What we would have said is, if VAX, do it the old way, else do it the new way. And then we wouldn't have had to change anything. But as it is, I just searched all of my code for alpha, AXP, I64, integrity, IA64, and started there. And effectively, any place you saw alpha or IA64, you add, then you modified it to say, or x86, because you want to perpetuate the bad decisions that were made 40 years ago. There's going to be some few cases, if you're using some built-ins, that may be a problem. If you're still running some kinds of alpha macro code on, you may have to do some work. Mostly not, and if you do, it's finally time to learn about libdollar table parse and zip-t parse. All right, where did we find problems? Now, a little bit of this is we were kind of on the early edge of things, so we got exposed to bugs that, like, by now are long since fixed and nobody else will see. Bugs in our code, uninitialized variables, abuse of the heap, a couple of assumptions about alignment of things that was coincidental all along. That's, as John mentioned, doesn't even happen anymore. So there was a couple of those. Data structure access that was inappropriate. Another example of a bug that just happened not to fail, so you didn't think it was a bug. The field testing of different bits and pieces along the way. Yeah, there's bugs. That's why they're field test, right? I mean, please help us find our bugs. Increasing quotas. People are terrified, in my experience, of numbers. So if you have, pick page file quote. Well, I ran out of it. How much more do I need? Add a 0. I don't care. Make it 10 times bigger. If that's not enough, do it again. I mean, don't be afraid of these. They're just quotas. Increase them. Even today, I find on customer sites, we'll talk about this later, but page faulting just a gajillion times a second. It's like, wow, you'd almost think that 8,000 pages would have been enough. But yeah, all right, less usual cases, very unlikely you're going to bump into any of this stuff. But there's a couple of different behaviors involved in signaling some of these values and how things happen. Don't worry about it. If you're programming in titanium assembler, first of all, you've got other problems. I'll tell you that right now. I mean, don't even worry about porting. You need help. Yeah, I mean, there's if you're in this level of code, you might need to do a little more work. If you have code that understands the computer, the calling standard, the layout of the image header, stuff like that. Best is undocumented interfaces. Oh yeah, we've been using this thing in VMS since forever. Doesn't exist anymore. You know, what's wrong with VMS? Doesn't exist anymore. Yeah, if you crash into any of those kinds of things during your port or during your investigations, get in touch with us or get in touch with VSI. I mean, they're all solvable problems. Some are easy, some are hard. So one of the first, and so I did a hello world right away to prove that it worked. One of the first things that I actually ported, completely coincidental, I mean, this was not by design, was an editor that was originally written in 1962, which is Tico. And does anybody, that was, yeah, I mean, this was.
Equine was still using it. I had to take it.
Build up until x86 still used.
So Tico is an awesome editor from the very old days. It's sort of like some other programming languages where the challenge is to type your name and then escape, and predict what's going to happen. Anyways, I downloaded Tico C freeware off the internet. I had to change a couple things to the build procedure. I compiled it, I linked it, I copied it over my container, and it ran. And an unnamed VMS engineer said, that's probably one of the least portable pieces of code that could run on VMS. And it worked. I mean, I have a timestamp up there. That was July of 2020 when that. So I sent it to Andy Goldstein. I sent this screenshot. He was elated enough that he didn't do anything else with it.
Because he goes several times. When Dan Murphy wrote it in the 60s, he did not write it in FATSMAC.
Oh no, no, it's like self-modifying macro code that every single rule of computing is broken by various versions of Tico. They do terrible things.
Yeah, the implementations.
Yeah. Flaw and runoff that I thought I was the only person battling. Like 5 out of 10 times, runoff would just blow up with this really weird error. I reported it to VSI. I think he ran it like 10,000 times in a loop until it failed.
Oh, I can fail it every time.
Well, okay, but at the time.
Anyway,
Anyway.
I know that. It's like, I can do that.
That's why he ripped it.
Anyways, but yeah, this was kind of a fun one. This is a latent bug that's been broken probably in ever, like since the 70s. But
nobody had been in the multiple states.
yeah. And anyways, so again, all of these changes in the subtle behaviors underneath means we're not bug for bug compatible. All right, legacy compatibility. This is again a totally unrelated thing. I happened to be looking up something else and I ended up falling into help job, which is a command I haven't used. I think I can confess in my career in VMS, I've never used the job command. It's for punch cards. Okay. This is forward compatible. In 2024, in x86, we have punch card compatibility. So I give VMS a lot of credit for.
We're waiting for the virtual card reader.
It's the virtual USB card reader.
It reads MasterCard.
I mean, I think this is kind of a cool thing to acknowledge that there is a job command on x86. Yeah,
I still use Jack on DCK in a lot of commands. That's also part of the.
Yeah. no, the ECK, like DEC and NDEC.
DCK.
And so as an aside, while I was making fun of VMS after I discovered the job command, it's been there since 1980. Charles Babbage was the guy that came up with the idea of punch cards, believe it or not. And he documented how they would work. He just didn't have to build one, but still, I think that's pretty cool. So another connection. All right, so let's talk about some customer application porting stuff. A customer of ours is in the financial security trading money stuff thing. And they asked if it was possible to port their application. They didn't ask to do it, but what they needed was the confidence to say, if we go to x86 in the future, it's a financial organization, a crisis, an emergency usually can get accomplished in about 6 months. So they move very slowly. But we wanted to, can we future-proof? Can you help convince us that we're on a good path? That 5 years from now, when our integrity, and the smoke comes out of the integrities or whatever it is, can we go to x86? And I said, all right, of course I said, absolutely. And then eventually there was a Pascal compiler. And so I took all the customer's application, what did I say, 100 modules, 100,000 lines of code, and all in Pascal with, there is an aside, and copied it over to our system, installed the field test Pascal compiler. Everything compiled with a couple little tweaks that we sort of expected. Build procedure had to be modified. Everything linked. You could run the program, and of course it would say file not found because I don't have any data. So I was like, yes, I feel extremely confident without having tested your application that it'll run fine. Pascal, like COBOL, is kind of an easy case because the language is pretty strict about stuff. It's more difficult to get yourself into trouble with those languages. They did have an interface with Polycenter, also known as what was it? Computer Associates, also known as VSI, and there's maybe another couple of owners in there too, Watchdog. So they call out to their Watchdog central server thing and say, I'm still alive.
That would be Broadcom. We don't.
No, yeah, Broadcom is probably, I don't know. Anyways, that module didn't exist, but I didn't let that slow me down. I just wrote a little empty stub that returned success to each one of the routine calls that they made. So yeah, problem solved. But so yes, the answer back to the customer is no problem. When you're ready, we don't see any impediments to doing a port. We'll solve those problems when we get to it. So another customer application, coincidentally, and this really is a coincidence, another international monetary exchange, financial based application. We had written for them some years ago. For their regulators, they needed proof that none of their executables got manipulated or tampered with. So we built them a little bit of machinery that approximately does a checksum of every file, stores it in a secure database, and then once a day they run it, make sure the checksums still match. Then when they deploy a new version of the application, the security interface guy or whatever it is approves each one of the modifications. It's written a couple of modules in BASIC, and I originally wrote this for them in C and handed over, hey, here you go. Oh, no, we don't know C. We know BASIC. So I had to rewrite the exact same application in BASIC. uses OpenSSL, a couple of RMS interfaces, pretty simple thing. I had to modify the build procedure and one source module because I moved to SSL 3. And the reason I found that we have SSL and then SSL 1 and then SSL 1.1 and SSL 1.1.1 and SSL 3 and all these things is because every version they change the interface ever so slightly. Instead of having a compatible interface version to version to version, they modified a little bit. So I had to modify one line of code to pass a new parameter or something. And the very first field test basic compiler that I was using, you compile it, you link it, and you run it, it blows up right away. Man, it was a bug. But John shared with me the secret workaround was just to add this combine link options file, and since then we've got good compilers. So if your application is written in Pascal or BASIC, I feel pretty confident telling you you're all set. Other languages, you're on your own. Oh, all right. So where are we today? This is actually a lie. This is from April when we were in Germany. So we're on the field test -3 release. A couple missing pieces of enthusiasm as well as software prevent me from being 100% native. I'm lazy. Kind of figuring out the whole landscape of database stuff. Other third-party products, we're not really dependent on anything. I know some customers, we've got one that uses a text to PDF or something to PDF converter thing. I don't know what the status is, but like that's their big fear is, yeah, one of those things. And I said, look, when you're at the point where you're porting to x86, we'll fix that problem, whatever the solution is. I don't know what it is, but don't not start moving now. So performance, my whole career's been spent doing performance stuff. So I was really excited to have a 3 levels of virtual environment to play with. Compilers constantly get better. Moving from the cross compilers to the native compilers makes a world of difference. So I've been playing around, running this and that, and my IO architecture is even more embarrassing than my virtualization architecture, so I'm not going to tell you about it. But yeah, it's a tough thing to measure accurately. Okay, that said, what I'm about to share with you, I take no responsibility for. These are non-scientific tests without adult supervision, probably done in the evening, with field test software, with field test compilers on a terrible architecture. These are non-dedicated machines. This is not a benchmark special. It's yeah, possibly. I'm no programmer. I'm no benchmark person. So everything I did was very naive. Do not spend money or make decisions based on what I'm going to share with you. Because again, I'm not responsible.
As a most thorough disclaimer,
I've been working on it. Actually, this morning at breakfast, I was thinking about how I'm going to frame this. Okay, so I took a handful of programs that I've had in my directory tree since forever. And most of this stuff is very old. I've been running it for years. And I ran it on a variety of architectures that I had available to me at that time conveniently without having to go jump through a lot of hoops. So my prime number generator program that I got off the internet a long time ago, I ran it on one of my emulated ES40s, another emulated ES80, which was quite a bit better hardware, a couple of different integrity systems, and then my x86 machine. And so this is fine. You know, this took 2 minutes to run, almost 3 minutes, took 44 seconds to 42 seconds, and took like 7 seconds. Is this a better compiler that does a better job with the prime number program? I don't know. Again, I'm not explaining this to you. I'm telling you this is what I measure. My little CPU mem program, it drags stuff around in memory, then does random accesses and a little bit of computation and stuff. Similar behavior. Again, is it VMS? Is it the hardware? Is it the compiler? I don't know. But this is what I measure. If this gives you hope for a better tomorrow, good. Now, probably the most famous benchmark among the people at this conference is VUX.com. And I'll tell you right now, it is an awful measurement of anything. But, you know, here we are in x86 field test software, and we're already faster than, by a lot, than our attainable. Now, what's interesting is we're almost as fast as our emulated alpha. Why would this be?
Is more better or less better
More is better
More is better.
than your better?
Oh, yeah, I'm sorry. I'm better than my alpha, but why is it so bad compared to those other slides where I'm 30 times faster? So the easy answer, I'm not going to bore you with the details, is DCL is a terrible place to program because it's interpreted, and DCL calls RMS for every single line of your command procedure every single time. And calling RMS means I go into executive mode, rummage around, do whatever RMS does, and copies data back into my buffer, goes back out to supervisor mode, where I then attempt to interpret and execute that line. So.
And did I mention probes? There's a lot of probes to all.
Yeah, these guys are yeah, VSI's blaming a lot of stuff on probes, which I think is convenient.
I explained to some of our newer BSI employees on the locations, DCL is by no means a well-written program.
Which official might be different.
Okay, so to kind of summarize this a little bit, we're getting to the end. It's a constantly changing landscape from a performance standpoint. That's been the case forever. Your salesperson will tell you there's another new computer coming out just next year. You know, we now have x86 computers, chips that you can buy that are over 6 gigahertz. Now, not necessarily in a huge enterprise class server, but nonetheless, they're out there. So faster computers are rarely worse. Might not be better, but they're not likely worse. VMS is going to get faster. All of these probes are going to get fixed, and the inefficiencies here are going to get fixed, and they're going to get fixed. The compilers are going to keep improving. They're going to generate smarter, better, stronger code. Storage, for $1,000, you can buy 27 terabytes of SSDI, 3 NVMe, whatever, all these acronyms. Spend money there. Like, if you're going to be spending money on your computer, this is where it is.
And do small lines.
And what?
Do small lines.
Yeah, do lot. Yeah. Well, my next session will badmouth doing IO. Where you're going to have to do some work, it's going to be in your build procedures. Most of your applications are not going to be doing any of the nasty stuff that we talked about with intermodes and call stack and yada, yada, yada. However, if you find /sysexy in your command procedures, maybe you're going to have trouble. If your end of month accounting summary involves floating point, you may have some trouble, but I don't think so. If you cannot build your application, if you're not convinced that you can build your application from source code today and have the version that you're running in production, maybe you need to worry a little bit. I've talked to some customers that pretty sure that the source code in the CMS library is what they're running on their production systems. Pretty sure. And I said, well, then I'm pretty sure that you'll be able to port. Take advantage of the warnings and stuff in the newer compilers. They can give you some pretty strong hints. Your latent bugs are not your fault. If you're still writing in Tico, good on you. Come talk to me. I'll get you Tico C. Otherwise, TPU or awk are good choices. Scan, any scan people here besides Ian?
You hope this get rid of that. No.
Yeah, so move that stuff to awk or TPU. Macro 32 alpha macro, just don't. If you're using ASM in some open source C or C++ code that you're porting, get help. This is sort of funny. Porting real applications to VMS integrity is, what vintage would that have been? Like the 90s? That's a worthwhile presentation to scan through because basically everything that was true then is true now, moving to x86. If you really care about floating point format, despite me telling you not to care about it, that's another good presentation or paper to read through. So x86 with VMS on top has been years in the making. It's the same. If you're not running it today, it's going to be really anticlimactic because all the commands work, all the outputs the same. Everything is just how it's always been. Don't worry about floating point, alignment, don't worry about it. If you've not worried about it yet, don't worry about it now. Compile and link, and if you have to, test. But otherwise, you'll be fine. So the last 4 years of all this porting stuff and field test and yada, 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 involved a tremendous number of people. I mean, it seems simple to say, oh, just port the operating system and you're done. But there's dozens and dozens and dozens of people and tens of thousands of hours of work. And I just want to give acknowledgement that we're standing on the shoulders of giants here. I mean, this is very, very hard stuff for an operating system that was designed in 1977, 78 is how old it is, and it still works with card reader commands. All right, give me questions, thoughts, comments. Yes.
Say anything about image sizes, and your linking, and also quotas. You mentioned a default quota, which had the 0. I like that. That seems.
Yeah. So quota wise, like all the time, I see byte lim is too small, and working sets are too small, and page fault quota is too small.
Working set, particularly on x86.
Yeah, working set matter. Again, it's just memory. Okay, a small system today has 16 gig of RAM. Use it. You know, I see customer systems frequently with thousands of page faults a second with massive amounts of free memory on the system because they've choked every single process. Don't do that. In terms of image size, so we went from VAX and image was this big, we go to alpha, now they're this big, we went to integrity, they got this big, and then on x86, the instruction stream is one size, but there's a lot of baggage that comes along with elf and dwarf and all this nonsense too. Is that what you were thinking?
Yeah, it seems to be a scary thing. This image is so big of this image. We haven't really.
Yeah.
As you said, a lot of the stuff that's in there, debug symbol tables, it's really not part of real application.
Anything else? Thoughts, questions?
So I don't know how I got under your last slide, but thank you. But I wanted to thank you for the work you've done helping members of the network team raised the bar on NFL.
So there's a really,
So much better, and you've been so much help. Thank you. I wanted to do that publicly.
you're very welcome, very welcome. Yeah, there's a bunch of funny stories about NFS. Like,
They're
as
not-
far as I'm concerned, VMS is just a platform to run the NFS client on. Anything else? Well, thank you guys so much for wasting it.